Hi, I'm Meta Spencer, and we're going to California today. We're going to see some old friends, Craig Smith and Bill Fletcher. These fellows have been on the show several times before because they're very, very interested in global warming, and they have written a book called Reaching Net Zero, which is the basis for some of the talks they have already given. Nowadays, along with the rest of us, they are very involved with and interested in the new IPCC report that came out a week or so ago, which is one of the many reports that the International Panel on Climate Change produces. So we're going to talk about that today. They're going to bring me up to date on what they have been finding about the details of this report. So hello, fellows. Hi, Bill.
Hello.
Good to see you. And Craig, hello.
Good morning, Meta. Nice to see you, and thanks for having us. I'm going to start off.
Go for it.
So we're going to be discussing the new IPCC Global Climate Report. And here's a slide. Good, thanks, Bill.
Mm-hmm.
So it's just came out, as Meta mentioned, a couple weeks ago. And it's the first major report that the IPCC has published since AR5, as it was the shorthand name for this, the fifth assessment report came out in 2014. So this is basically 5 years later in terms of data. The total report is 3,800 pages, hundreds of authors from 66 countries. And we're going to be commenting on a summary that the IPCC made that's available to anyone to see, which is 40-some pages, and it's called a summary for policymakers. But it has the key findings of the report, and we have assembled them in a way that hopefully is more user-friendly, and we've kind of stripped out some of the technical qualifications and so on, so that it's easier to follow. And the first major topic we want to talk about is the warming of the Earth, which of course is very much in the news today. And I just will quote the first conclusion IPCC made, and that is, they said, it's unequivocal that human actions, human influence has warmed the atmosphere. And a couple of notes about this IPCC report. It's not necessarily more bleak than previous reports. It is in some regards. It's also more forceful. A lot of the conditioning of statements has been removed, and there are very definite opinions being expressed. And also there's some explanations that counter previous criticisms of the work. But more on temperature. During the most recent decade, these temperatures exceeded the most recent multi-century warm periods around 6,500 years ago. Prior to that, the next most recent warm period was 125,000 years ago. So I think it's pretty obvious, in spite of what people might claim, that temperatures are increasing all over the world. And the IPCC makes a very definite statement that temperatures are going to continue to increase for the next 100 years, even if emissions stop today, which of course they're not going to stop today.
There's a lot of criticism of models used and so forth by climate deniers, but there's some just hard facts that are hard to avoid. And I think the two are that the concentration of greenhouse gases, mainly carbon dioxide in the atmosphere, are steadily increasing, and that's irrefutable. And that the temperatures of the Earth are increasing in direct proportion to the greenhouse gas concentrations in the atmosphere. And these are carefully measured values and are probably the strongest indication there is about global warming. The other one you throw in there is the sea level rise. And in the report, they report that the CO2 concentration in the atmosphere has reached 410 parts per million, but that's in 2019. A recent report, and these figures are reported probably monthly, is more like 419 ppm. So the march upwards is not being affected at all. Interestingly, you see this graph, there's a black line, which is the average, and then there's a red line, which is like a sawtooth. And what that is that during when the northern hemisphere is in its growing season in the summer, that absorbs more CO2, and the red graph line goes down a bit. And then in the winter, when the growing season's over, it goes back up. So that's what it is. Another thing I think that Craig and I are very concerned about, because a lot of people think, oh, well, in the last 150 years, we've done this or done that. But 50% of all of the greenhouse gases in the atmosphere today were put there in only the last 30 years. I mean, that's astounding. And that's a scary number. And the other one today is that we're putting in about 55 billion tons of greenhouse gases, about 40 to 43 billion of that is carbon dioxide every year. And although there was a little bit of a reduction due to COVID, when the airlines stopped flying and people stopped traveling, this has bounced back, and we're right on. We're not seeing any reduction in emissions. They're high and they're continuing to grow as in the past.
I want to mention about glaciers. I had some friends of mine who were going to go to Glacier National Park in the United States last month, and I told them, hurry up and go, because in another decade, there aren't going to be any glaciers left in Glacier National Park. The number of glaciers there has dropped precipitously in the last 30 years or so. And IPCC takes the broader picture and points out that human influence is the most likely driver of the global retreat of glaciers since the 1990s. 1990s, 30 years ago. Almost all the world's glaciers are retreating in synchronization. It's unprecedented. The amount of melting and retreat of glaciers is unprecedented in the last 2,000 years. They also make the statement that mountain glaciers are committed, based on the amount of greenhouse gases in the atmosphere today, to continue melting for decades or centuries under current trends. The ultimate outcome of that is more water in the ocean and more sea level rise, but we'll get to that later. Bill,
that also involve a loss of water from rivers that are fed by glaciers, which would mean a problem for irrigation of farmland in some parts of the world. I think of India and China particularly. I don't know about other areas. I believe also some places in South America, it's going to create water shortages for farming.
And India, they depend on glaciers in the Himalayas for their main river source. That's the source of their big rivers. We're very interested in what's happening in the Arctic. It's heating up. It's the fastest changing part of the place in the world. The Arctic is heating up about 2.5 times faster than the global average. This is a NASA chart showing the heating up of the Earth. And interestingly, you can see in the Northern Hemisphere how much hotter the Arctic is, and it's 2.5 times faster than the rest of the world. Interestingly enough, this little area, the white area there, is actually a cool part of the ocean. And the reason that is cool is because of the Greenland ice cap is melting and putting more cold water into the North Atlantic. So that's the reason for that little.
Neil, I got a caveat on that because just yesterday I did a show about that very question, and it's Paul Beckwith is a climatologist who seems to be following this. We were talking about the conveyor belt of the circulation system currents in the ocean, and there used to be a what they call a chimney up in that area, inland area, which is where the water would go down and then go back toward the south again, very deep, because of the cold water. Now, he said that it was thought that it was the melting of the Greenland's ice sheet that was causing this area to be the coldest. But he says that's not the only reason, or that maybe it's not even the main reason. It has something to do with the circulation pattern there. So
I would defer to him. I mean, he's obviously more of an expert in that than we are.
Anyway, it's a very important thing that there used to be this chimney there and they don't have it anymore. So what they have to do is figure out where it went or what happens instead, how the water is circulating without that chimney. That's what they call it, where it's like a funnel where all the warm water goes down or gets cold and goes down. Okay.
I want to make one or two more points too. I mean, one thing that the report clearly hits is that the Arctic sea ice was, and this is the late summer when it's at the minimum, was smaller than any time in the last 1,000 years. So that's a startling statistic. And it's the projection is that the Arctic will be practically ice-free by the middle of this century, like 2050, or around 30 years from now. And I think one other thing that we would, and the Greenland ice cap is definitely melting, and that is considered to be irreversible. It will continue to melt as long as CO2 concentrations are high. In the Antarctic, which is the other pole, there is melting, but there's less of a concern about a massive failure of an ice sheet or something like that. I think that the difference is that in the North Pole, there's open ocean and it's ice on the water. The South Pole is a large continent with a mile thick ice cap on it and is much colder.
And also, it seems
more slowly.
The other part is that this orange spot, the red spot that you show on the map, is all at the north. Now, you would think if it was just a polar thing that the South Pole would also be red, but it's not like that. It's all concentrated in the Arctic, and I don't get it.
Well, I mean, it looks like the Northern Hemisphere is going to be affected much more strongly than the Southern Hemisphere. I mean, that's not a conclusion in the report. That's just something that I would speculate on.
Okay.
I want to take a different slant and talk about the warming of the ocean. It's virtually certain, according to the IPCC, that the surface level, that's the top 700 meters or top several thousand feet of the ocean, the global ocean, is warmer than it has been for many times in the past. And it's warming faster every decade, which is another interesting thing. It's increased compared to the average baseline temperature, which is IPCC defines as the average temperature from 1850 to 1900. Compared to that, average temperature of the ocean is increased 0.8 degrees centigrade, or a little over 1 degree Fahrenheit. And they make the bald statement that past greenhouse gas emissions, that is, the greenhouse gas is already in the atmosphere, have committed the global ocean to warming over the rest of the 21st century. So we're not going to see any lessening of warming, and we'll come to that effect of that later, but that has something to do with sea level rise.
Yeah.
They'll tell us about other effects on the global ocean.
Well, yeah, I think the other easily measured and in my mind, very significant effect is that the ocean is becoming more acidic based as its pH measurement is higher. And the reason for that is that it's absorbing a lot of CO2 into the ocean where it's converted into, I think, is it carbonic acid, Craig? That increases the acidity of the ocean. So it's absorbing enough, something as large as the ocean is absorbing enough CO2 to actually change its acidity. They're saying that this is probably, I'm just trying to look at the notes here. It's as with temperature, the greenhouse gases in the atmosphere today have committed the ocean to continue to get more acidic for the rest of this century at least. And that's a good example of what Craig and I are concerned about, which is latency, the delayed reaction to the damage we're doing to the environment. It takes a long time for some of these effects to show up.
And of course, more acidic seawater means less coral. The primary impact of increased acidification is damaging coral reefs all over the world. And we're seeing that already most dramatically in Australia, of course, in the Great Barrier Reef.
That it's harmful to shellfish because they can't produce.
Oh yeah, yes, that's right. Well, the sea level rise continues, as we mentioned earlier, and it's gotten more per decade as time has gone on. Most recently, a couple of millimeters per year, and then after 2006, up until present time, it's up to about 3.7 millimeters per year. Those seem like very small increments, but built over a long period of time, it's significant. So the rise to date has been about 10 inches from the baseline of 1850 to 1900. And that is about, according to the IPCC current report, about 50% of that rise is due to expansion, thermal expansion, because the ocean water is warmer and it expands as it gets warmer. And the balance of it is roughly a quarter from glaciers and a quarter from ice sheets and a little bit from fresh water running into the ocean due to things like failures of dams and so on. And it's virtually certain, according to the IPCC, that this rise is going to continue and it continue increasing during the balance of this century. They also state that its anomalous forecast is that there could be sea level impacts or events that today occur maybe once per year, could occur much more frequently near the end of the century. And they say at half of all the tide gauge locations in the world. Well, tide gauge locations are typically near beaches, shallow coastlines, and so on. That rise under the various scenarios shown in the slide that Bill put there range up to 1 meter, very high impact. The top dash line That is basically the business as usual line. In other words, if we don't do anything to curtail greenhouse gas emissions from now to the end of the century, that's where we might see sea level rise go. The lesser categories or scenarios shown on the curves down below lead up to typically say a half to 1 meter. Well, 1 meter is 3 feet, a little more than 3 feet. And many areas of Florida, coastal areas of Florida and the southeast United States are 3 feet above sea level. So that does not augur well for property values in those coastal areas.
The IPCC's report states unequivocally that climate extremes are being hit in every region of the world, and they would highlight extremes such as heat waves, heavy precipitation, droughts, and tropical cyclones. A cyclone would be basically a hurricane in our terms, or I forget what they call them in the Pacific. I should know.
Typhoon.
Typhoons.
Yeah, there you go. Very good.
And it's virtually certain in their minds that or in their report, that heat waves are becoming more frequent and more intense across all the regions since the 1950s, and that cold extremes are getting are less and less frequent. It's also likely that the global frequency of major tropical cyclones, typhoons, and hurricanes will increase, has increased, and will continue to increase. And the greater the temperature growth, the greater the frequency and intensity of these storms. It says that they also point out that the weather, as we talked about with the Arctic, in the Northern Hemisphere is becoming more unstable with more extremes. It's the jet streams being affected and becoming less predictable, and that's leading to heat waves, droughts, tropical storms, and floods that we're getting reported in the press. And I think one other thing that they have highlighted that's interesting is what they refer to as compound events. And a compound event is when you hit with more than one thing at the same time. A good example would be what we're going through in the Northwest now. We're getting hit by a heat wave, a drought, and then a wildfires all at the same time. So a compound event would be where more than one change is hitting you at the same time, and that the consequences are more serious than if you had those events occurring by themselves. So I think it's getting increasingly obvious to the general public that the weather is changing. And hopefully people are going to get concerned about it. I think I'll mention one last thing here. Craig and I have pointed out in our book on a number of occasions that, with climate change, we have not had a 9/11, a Pearl Harbor, a Sputnik moment. We haven't been slapped in the face with some big event that forces us to recognize the problem and do something about it.
Big fire in Northern California has now surpassed 1 million acres. I don't know if it's the largest single fire in California. The last I read, it was, I think, the second largest fire. And then there's another huge fire in Russia that we don't see much about. That's even larger. It's burning, out of control, unchecked in Siberia, of all places. So fires are certainly approaching the point of being maybe not a Pearl Harbor, but they're certainly significant when you see entire town just going up in flames.
The Siberian thing, is that actually also tends to melt the permafrost, which then starts the microbes chewing up the old decayed stuff and spewing out methane, which is so much worse than CO2. So in a way, the Siberian fire is even worse.
Yes, very good point.
In today's Los Angeles Times, there was a big article on wildfires, and it's interesting that already we've burned 1.3 million acres, and this is early in the fire season. And the concern is that, September and October are usually the worst months because we get what's referred to as Santa Ana winds. These are winds from the desert that are very intense, and they do two things. They dry out the wood, the forests even more, and then they fan the flames. So if anything, we're looking for a potentially much worse fire season in September and October. And the other thing is that there was also recently reported that July last month was the hottest month on record.
Is that they say that global surface temperature will continue to increase until at least the mid-century. More likely until the end of the century. But the only way they could start decreasing at mid-century would be if we the world, start immediately with very rigorous global greenhouse gas emission reduction programs. And that would be the only way that we could slow this down by mid-century. The IPCC summarizes by saying global warming of 1.5 degrees C and 2 degrees C will be exceeded during the 21st century unless deep reductions in CO2 emissions are made. You recall in the Paris Treaty, the objective was to hold hold the average temperature to less than 2 degrees centigrade and preferably to 1.5 degrees centigrade, and to do that by 2050. Well, it's very clear to us, and I will say this is our appraisal, Bill and I, that we are not going to achieve 1.5 degrees centigrade by 2050, and definitely not 2 degrees centigrade, probably not by the end of the century even, unless we have a very aggressive immediate start on reducing global emissions. That's unfortunate, but that's the way we see it, and IPCC is coming to that same conclusion in this. They say that global surface temperature in any year can be more or less than the long-term human-induced trend due to substantial natural variations. So, for example, they mentioned that a major volcanic event, explosion, would add to the atmosphere gases, sulfur dioxide, and so on, that would reduce solar heating of the Earth. But that would be a temporary thing for 1 or 2 years. And then as those aerosols go away, the temperature comes right back. And it has nothing to do with the release of greenhouse gases. So the gases will keep building. And once the aerosols are gone, we get hit with even higher temperatures. So
in our book that came out a year ago, a little over a year ago, our forecast was that we're going to blow through 1.5 and 2.0 degrees C. There's no way we're going to meet those objectives because we're not going to respond fast enough. And I think that with the latest report, the IPCC is coming close to agreeing with us.
Many changes in the global climate system become larger in direct relation to increasing global warming. That's another fundamental conclusion that IPCC makes. And so, in other words, as there's more greenhouse gases put into the atmosphere, some of the changes become even more significant and larger. For example, it's likely that the land surface temperature will increase more rapidly than the ocean. And what happens is that as the increase in greenhouse gases goes on, the ocean is less, I'm sorry, the land is less able to absorb gases, and the ocean is less able to absorb the gases, and so more gases go into the atmosphere. The larger cyclones or hurricanes that will also tend to move more towards the poles, in the northern hemisphere, the northern pole. And
So
again,
hurricanes are going to go farther north or farther south than they do now?
in the northern hemisphere, they're going to move northward, correct?
Really? Uh-huh.
And the northern hemisphere, as Bill mentioned earlier, is the part of the Earth more subject to these changes than the south.
There's a couple of graphs here that we have that we've taken right out of the IPCC report. And this is the forecast. And I think the interesting thing here, if you can follow the cursor, is it shows that the growth in the Earth's temperature over time, and it shows approximately where we are today and the rapid change. I think another thing that I think is very interesting, because a lot of, some people say, oh, well, the global warming's natural. I think this is new for this current report, is they really went back and tried to say what would be the temperature of the Earth if humans' influence was zero, and to try to address that issue. And here we can see the simulated natural only with solar and volcanic. And so basically they're saying that the Earth's temperature would not be increasing at all compared to the impact of human change on that. So the impact of humans is pretty odd. The changes are all due to human impact. Here's just a range of scenarios, and I think that, and this is carbon dioxide, not total greenhouse gas emissions. The total would be about 25% larger. And you can see that we're basically on this upper chart, upper line rather, of ongoing increases that would double carbon dioxide emissions by only 2050. And then you can see there are other simulations that they've done all the way down to what it would take to get to net zero by 2050, the lower blue line. And that's what would be required to reach, to keep global warming under 1.5 and 2 degrees C. And you can see there's a huge gap between where we're going and where we need to be.
Move the cursor to 2050 and on the top curve.
That's right.
There you go, right there. Now I'm
exactly on 80. Yeah.
I'm very proud of that number, because that's what we had in our book as written before this came out, as what would be happening in 2050 with business as usual. And we're proceeding on that curve right now, unless we do something drastic. And no matter what we want to say, the political approach to dealing with global warming, I think the analogy, I heard this a long time ago, it's like the mating of elephants. There's a lot of trumpeting and stamping of feet, but any positive results are at least 2 years off.
Yeah. The ocean and the land carbon sinks have really absorbed vast amounts of greenhouse gases. And the ocean, for instance, has absorbed over 90% of the heat from global warming. The ocean's a giant heat sink. And only about, I think, is it 30% or so of greenhouse gases stay in the atmosphere. The rest is absorbed either by plants on the land or by the ocean. And the best estimates of the IPCC is that as the total concentrations increase, the ability of the land and the oceans to absorb greenhouse gases, mainly CO2, could start to decrease. And that would mean that more stays in the atmosphere, which would mean that global warming could be accelerated. As we put more and more stuff into the atmosphere, the mechanisms for absorbing that are weakening. It's not dramatic. I don't think they're predicting any catastrophic change, but just a slow deterioration which should worry all of us.
Yeah, the other finding that IPCC has articulated in this report, where I don't recall it in the previous reports, was that many of the changes we're seeing now, and as gas emissions continue to increase, are going to be irreversible. And they say irreversible for centuries to millennia. And they're talking about changes in the ocean, changes in ice sheets, and in global sea level. Well, that's a very concerning issue, and that we can't turn this around. Certainly, we're not going to stop global emissions today or tomorrow, and even over the time frame that it's likely we might be able to get the world to take action, these changes are going to continue, and they're not going to end during our lifetimes or even by the end of the century. They're going to continue.
What goes in the atmosphere stays in the atmosphere. This is something we put a lot of emphasis on. It takes hundreds of years for carbon dioxide to be naturally absorbed by the land and the ocean.
They state that based on ancient history and current records, that we're likely to have one major volcanic eruption during the next 50 years. They say at least one explosive volcanic eruption during this century. And that, of course, would mask some of the effects of ongoing global emissions. But it's just a masking effect. It doesn't change anything. And we continue putting out CO2, and it continues building up in the atmosphere.
One thing that Craig and I were very concerned about, and Meta, we've talked on your show about this, is what we would call tipping points, where and the latest report does discuss the fact that there are tipping points out there where we would reach some point where something would happen, like a major collapse of an ice sheet or a sharp reduction in the ocean currents or something like that. And they're saying that, if anything, I would say that they're saying that they're less likely, they're out there, but they're less likely, we're less likely to exceed one of them in the next, this century. It's a possibility, but not a high risk. If one did occur, it would be a rapid and abrupt change that would be very noticeable. And, you know, something like the collapse of the monsoon or something like that, that would have a dramatic impact on the weather in parts of the world.
Right, and not something that we can do anything about very quickly.
Yeah.
Or even the shift of the Gulf Stream could freeze Europe.
Well,
yeah, Meta, you're right about that, and they do talk about that in this report. They refer to the Atlantic Meridional Overturning Circulation. That's a fancy name for the movement of the Gulf Stream up towards, along the coast of the east coast of the U.S. up to England and then back down, and that brings warm water to Europe. So they're saying that it's likely to weaken over the 21st century. And they're saying that a major weakening or collapse of that would have very significant effects on European weather and weakening of monsoons in Africa and Asia. But they say the probability of that is pretty low at this point in time. It's something to think about, but it's changing, but very slowly. So they don't give a urgent warning about that. It's something to think about.
If we want to limit future climate change, there is no alternative to just limiting the cumulative CO2 emissions and the emissions of other greenhouse gases to reach net zero as quickly as possible. And there is no alternative to that. If we're not willing to do that, then we really can't do anything about global warming. And that's something that Craig and I would like to emphasize again and again. Some of the climate deniers, they'll say, oh, gee, look at Texas. They had this problem in the wintertime. That proves that wind power isn't going to work. What's the alternative? Are we going to be able to continue to dump 55 billion tons of greenhouse gases and other pollutants into the atmosphere forever? And that number is increasing, as we discussed earlier. And the answer is no, we just can't do that forever. And what's the alternative? We have to stop someday. And the answer is when. And it will require some very significant changes, but Craig and I believe that they're certainly possible based on the technology and the economics of what's available today.
Earlier, they talked about a carbon budget in the earlier report, but in this report, they state, and I'll just read this, that for every 1,000 billion tons of CO2 that goes into the atmosphere, the temperature rise is going to be about 0.5 degrees centigrade. They put a range on it, but they specifically say, put in 1,000 billion tons of CO2 and the temperature is going to go up 0.5 degrees centigrade. To me, that's a very remarkable kind of conclusion. That sort of tells you where we're headed if we don't do something. The other thing, and Bill, I'm talking about items 16 and 17, and I'm going to leave the last conclusion to you.
Okay.
But they also say that their estimate is that since the base period, that is since 1850 to 1900, which was sort of pre-industrial revolution, that they've determined that about 2,400 billion tons of CO2 have gone into the atmosphere during that time. And so you can determine then, based on what carbon intensity in the atmosphere will cause a given temperature, you can determine then how much more carbon we put in the atmosphere to not exceed 1.5 degrees centigrade. And they say about 400 billion metric tons of carbon dioxide additional, and we'll be at 1.5 degrees centigrade. Well, in terms of just carbon dioxide, we're presently putting about 40 billion metric tons a year in. So 400 more metric tons of carbon dioxide, that's 10 years. So that means that we would reach 1.5 degrees centigrade in 2031, 2032, somewhere around there. And they give similar numbers for reaching 2 degrees C. And I won't go through a whole bunch of numbers on it, but just to say that it comes out at the end of the century. So in other words, the prognosis is we're not going to be able to hold the temperature below 1.5 degrees centigrade or 2 degrees centigrade by 2050, which is what we said a year ago in our book.
Here's the IPCC, another chart from their report. And the lower one would be if we took aggressive action immediately and stayed under 1.5 to 2 degrees C. And the top line is what if we continue business as usual. And I think the forecast is that by the end of this century, we could, if we don't do something, we could easily exceed 3 degrees C. Depending on which one of these paths we stay on for the next 60, 70 years. They're saying that, hey, if we took aggressive action today, we've got a lot of latency into the system. The oceans are going to continue the sea level is going to continue to rise, et cetera. And if we took aggressive action, maybe 20 years before we start to see results, just because we're basically trying to turn around a big ship. I don't think we need to beat that up. But there's a lot of damage that has been done that hasn't shown up yet. And that is a big emphasis of the report. And if we started to do the right thing tomorrow, we won't see any immediate effects.
Everybody was hoping that the one positive benefit of the pandemic would be to reduce greenhouse gas emissions. And according to IPCC, there was some reduction in air pollution and some reduction in greenhouse gas emissions. But overall, atmospheric concentrations of CO2 continue to rise during the pandemic, just as they had before. And of course, now with the easing of all the travel and other restrictions, the emissions are coming right back up to speed.
Yeah.
Meta, any other comments?
What I wonder is what they say, if anything, about negative emissions. What do they say about doing, sucking CO2 out of the ambient atmosphere and sequestering it, either through natural means, such as forestry and agriculture, or through some type of technological means, such as brightening the clouds, or there's another project that I'm keeping my eye on, which would be a way of putting aerosol iron into the atmosphere to capture methane and break it down. So there are a number of things that are technologically sophisticated. Now, I had a conversation. First of all, I want you to answer my question. Do they even talk about it?
I certainly confess I've not read the 3,800 word or page report. But in the summary report, they talk about direct carbon capture, I think is the term the IPCC used. And they mention that there are people doing research on methods to extract carbon directly from the atmosphere and quote unquote store it safely underground. It's kind of interesting they mention that. They don't attach any likelihood. They don't say it's very likely we can do this or it's highly improbable. They just mention it, and that was it. I did not see anything on the other subjects that you mentioned, the so-called geoengineering. But I'm not sure that it's not mentioned, but I did not see anything. Bill, I don't know if you have any added information about that.
Well, I think that Meta, there was a brief mention, but this report is not focusing on what to do about the problem. That I think there'll be some subsequent reports. This report is really focusing on the physical evidence of what's actually happening.
Okay, that's a good point. Yeah.
Yeah, and so I think that this is a state-of-the-art assessment of what has happened due to global warming and what is likely to happen in the rest of this century. And they do mention that, if we want to stop global warming, we've got to stop greenhouse gas emissions, the sooner the better. And that, I think that to say what alternatives there are and what do you do about carbon capture, Craig and I have strong opinions on that. There's a lot of people, not a lot, but there's several people working to come up with that solution. But even if it works, it's going to take a tremendous amount of time and money and energy to suck carbon dioxide out of the atmosphere. Our estimate was that it would cost $1 trillion to reduce CO2 concentration, just 1 ppm.
Okay, let me say, I certainly agree with your general assessment of the direct carbon capture prospects. Everything that I have read, I was very hopeful about that a couple of years ago, but I'm following as much as I can about I don't want to call them alternatives, but other things that can be done. And that is one of them, but I would say it's probably the least promising. There are other things that are much more promising. But I think the unfortunate thing is that these are thrown together in the term alternatives, as if there were some alternative to reducing emissions. There is, you've pointed out quite correctly, there is no alternative to reducing emissions, because everything else that you might want to do that would help the climate or the temperature of the planet would not solve all of the problems that have to be addressed by reducing emissions. For example, the acidification of the ocean, et cetera. There are a number of things that are going to, that cannot be solved in any other way. However, there are things that could be done in addition to the reduction of emissions as fast as possible, which would, in fact, reduce, I think, temper the temperature rise. One of them is the brightening of the clouds. Another is a project that's still in the offing. It's not even got a pilot project underway yet, but it would be putting iron aerosol into the air to break down methane. And I've done talk shows about both of those projects. There are other things that may be also promising. I don't know. We hope so. But, yesterday, or not yesterday, 3 or 4 days ago, I had a conversation with a young man who had worked at the IPCC. He's now affiliated with something called the Climate Action Network, Eddie Perez. And I told him that it bothers me that people who want to promote the idea of a global emission reduction studiously avoid any mention of the potential value of negative emissions, which could be not only these things that I've mentioned about brightening the clouds and capturing using iron aerosols, but also simpler things. Definitely improving agriculture is important. Sequestering carbon into the soil, sequestering carbon through forestry would be another approach. And those are natural methods that we could step it up and put a lot more energy into doing that quickly. And I said, I don't understand why they avoid the topic. They pretend that there is no, what they call alternatives. Yeah, there is no alternative, but there are other things that can be done in addition to reducing emissions. And there are very important possibilities. And I said, I thought that it was really offensive for people to hide these things, as if by mentioning the possibility that we could get any benefit from things like forestry or agricultural change, that we would, people do this, I think, because they don't want to give people any illusions that maybe they could do it instead of. And he said, yes, that is really the case, because that is the reason why they don't put any emphasis on negative emissions. They, in fact, almost ignore it and deny, and well, deny is a strong language, but they don't talk about it. And I find that really depressing, because there are things that could be done in addition, which need to be addressed very quickly and rapidly and with a lot of intensity. And he gave examples of some corporations. that he said, I don't know whether it was Shell or one of the other oil companies, put out a plan claiming that they were going to do a lot to reduce global warming because they were going to do offsets. Whenever they're going to be still putting out CO2, of course, through fossil fuels, but they claim, well, that we're doing our part, we're doing a lot because we're going to plant so many acres of trees for every bit of CO2 that we emit. So they're using it as an excuse to continue emitting. That's the thing, and it's because people don't want to give them that loophole to use as a phony excuse for continuing the emissions, that there is a studious effort to avoid even mentioning the potential value. And I think it's really time now for us to talk about not only doing everything at breakneck speed that we can possibly do to reduce emissions, but also do everything that we reasonably can do without any major risk of unwelcome side effects, to adopt but additional methods of negative emission, taking CO2 and methane out of the atmosphere and sequestering it. So,
Meta, we would certainly agree. We would agree with that last point you made. In fact, agriculture and forestry accounts for about 25% of emissions. That is from fertilizer, machinery, cutting down trees, for forest fires, and all that stuff. And we would certainly agree that there are many things that can be done about that and could be done immediately and would be helpful and supplemental to anything else. Absolutely agree with that. We say, we need to plant 1 billion trees. We need to have better methods of raising crops with less fertilizer and so on and so on. As far as the oil companies getting offsets, I mean, that's been going on in California. We have a so-called cap and trade program, and it's not been a success. It's been actually a failure. There's just too many ways it can be gamed. We've given people offsets, meaning they can dispose more carbon dioxide into the atmosphere in exchange for planting trees. And then we find out that the trees that are going to plant are going to be harvested immediately, or they're for a lumber company that's going to go cut them all down anyway. So there's been a lot of misuse of that program, and that gets back to the fundamental idea of just a fee on carbon.
Absolutely. Yeah.
Where Canada is doing that, and then Canada is a leader in that, and since they started a number of years ago. And we just hope that the U.S. and other major countries are going to do that soon.
I don't see it happening in the U.S. I think they're scared to death. You even talk about a carbon tax, or you use the word carbon fee. I don't blame you, because it scares people, and the politicians worst of all. So that's the most valuable thing that can be done: a carbon tax, a good steep carbon.
I think a fair tax would be at least the same as the cost of actually removing carbon dioxide from the atmosphere. So if it's going to cost you $100 a ton to take it out, you should be paying that or more for putting it in.
Thanks so much, Bill. And
thank you.